This meeting is being recorded.
Okay, good morning, everyone. Today we continue our discussion on linear programming, as a general topic, prescriptive analytics. So, by the way, don't forget that you have almost 1 month to submit your final project. I've looked at your deliveries, and I think I posted your your grade for the first project delivery. Actually, the most of the topics are good. For some of you, I provided some comments. And I guess a few of you had some misunderstandings, so I gave you some feedback to resubmit, so you can get the full credit. But most of the grades was 100, just I think a few of you need to fix and resubmit. So hopefully it will be a good project. I've reviewed all of your projects, and basically, I think there is some general workflows, that I can teach later, so it would help most of you. But there's a vast, a wide variety of topics you selected. For some of you, I may or may not have time to provide a workflow example. So you have to search by yourself, and there's plenty of workflows that you can hook on it and basically use it for your final project. For example, I think one of you was about some time series. So hopefully, if I have time, so I will cover that. Otherwise, just search for how to predict time series, like for example, COVID cases. So, or maybe Bitcoin price. So for those cases, you get some workflow examples that you can use for your final project. One of the things that I want to cover in the next class is how to do feature selections and how to focus on importance of features. Let's say I'm just giving an example of one of your friends' project was about factors affecting COVID in different regions. So the outcome was number of COVID cases, and we want to predict with a high accuracy. But what's the point of predicting with high accuracy? Let's say you predict number of COVID cases in Worcester with 99% accuracy. So what? So most likely in those cases, more specifically in the healthcare domain, on top of high accuracy, the most important thing is what are the important factors. Let's say I'll just throw in some reasons, may or may not be correct. So maybe in the Worcester, people use more public transportation, and there's not that much of good parking. So, and when people expose themselves in the public transportation, they may get COVID easier than somewhere like Shrewsbury. So Shrewsbury is a residential area. People can easily park. So, they can use their own cars, but in Worcester is kind of challenging. So let's say in that research, you understand that parking is a important factor or important variable. So maybe you can recommend Worcester City to have more parking areas. So in the case if the future we have another outbreak, so people are easily can use their own car, and they less depend on public transportation. Or I haven't seen any public bicycles station in the Worcester, which you see in the Boston. So let me just give me 1 moment.
This meeting is being recorded.
So it's me 2 weeks ago in Boston. So as you see, can you see the picture? So I'm having a blue bicycle.
Yes.
Yeah.
Okay, cool. So looking at that blue bicycle, maybe if I live in Boston, I don't have to use, and I have parking issue, I cannot use, instead of using public transportation, which I'm prone to get COVID, maybe I can use those blue bikes, do my shopping or do my transportation. So there's a less chance of getting COVID. So there's a plenty of suggestion that you can provide for people. Again, some cases like COVID, maybe you are more interested to find factors are associated to COVID cases, not exactly predicting. Okay, so again, based on the feedback I got from your submissions, we have another lab for working with NIME. So in that, I'm trying to show you more workflows that helps for most of you. But again, I may or may not have time to cover all needed workflows. In those cases, you need to do search by yourself and basically find the associated workflow. And maybe you need to do some study by yourself. Okay, so last week, we started prescriptive analytics, and we had two approaches. One visual approach, which we did some examples, and we start talking about formulating linear programming. So linear programming is a method that you can use for solving prescriptive analytics, or generally speaking, operation research problems. Let's say for predictive analytics, you use SVM, you use decision trees, or like neural network. For prescriptive analytics, we use linear programming to solve the problems. I mean, last class, we had a very basic prescriptive analytics problem, and we tried to solve it through visualizations. And some of your friends reached me later and blame me for limitation of the method or other issues. So looking at the previous class problem, can you give me some issues about that problems or how we can improve our solutions? I'm not sure if those guys who reach me are online now, but in case you're online, I think it's easily you can pick the issues. Okay, in case you forget that mistake. So in that problem, we looked at continuous variables. But it makes, I mean, let's say for hash browns or sandwiches or similar problems, we are more interested in integer values. For example, doesn't make sense 0.3 of hash brown or 0.24 of sandwiches, right? So for those cases, we look for integer solutions, not every solution. But again, it was a very basic problem. And another one, last class, we had two decision variables. I'm just giving an example of that hash brown and sandwich. I mean, for the meal problem. So in that case, we decide about number of hash browns and sandwiches that satisfy our policy in terms of number of calories, proteins, those, so on and so forth. With two decision variables, you can draw on a piece of paper and you can solve it. But let's say you have 10 decision variables. So the problem has 10 dimensions. For human, it's very hard to do visualizations for more than 2 or 3 dimensions. So that visual approach may not be feasible for more realistic problems that you have a lot of more decision variables. Having said that, so for those cases that you have so many variables, and we are limited in terms of doing a visual approach, we do linear programming approach. So that linear programming groups has basically the most famous one is Simplex Method. There's other methods. So Simplex Method is a very intuitive method. We don't go to the Simplex Method. It's If you're interested, you can get some courses in the math or industrial engineering. But basically, there's the mathematics. In that math, we search all of the points. So you remember we said that optimal solution should be on the points of the feasible region. So basically, Simplex Method just search those points and find the most efficient. Like it could be the maximum value or minimum value. For this course, we use Excel solver for those large problems with multiple dimensions. And later, there's even an easier software that hopefully we have time go through that. So with Excel solver, we don't have to do graphical analysis and just draw the lines and feasible region. Just Excel just make those feasible region inside its memory and then search for those edges and points and give you the optimum solution. So for the case of integer solution, like number of hash brown and sandwiches, there's a method that's called integer program. For like network problems, we have network modeling, goal programming, multi-objective optimization, and so on and so forth. There's even more algorithms that hopefully we cover most of it. Okay, so today we start doing a spreadsheet modeling, and we talk about some language of this domain, like what is the binding constraints, slicer price, shadow price, and we look over some applications. By the way, I'm not sure how many of you are from MSBA program, but you have seen that many of these courses in this domain needs hands-on experiences. You don't learn by just reading the books or like memorizing formulas. You need to make your hands dirty. So more specifically in prescriptive analytics, the more important part is how to formulate the problem, and the remaining you just give the software to solve it for you. So for doing formulation, you need to see more type of problems. For example, make versus buy type of problem. So if you see one type of it, probably you can easily solve the next problem. Or for transportation problem, if you see one example and go through that and solve it through linear programming, the next one is much more easier. So again, for success in this section of the course, there's not that much of reading. You just need to do experiences. Could be some aspect could be easy, in some aspect could be challenging. But the good part is we appreciate your experiences, not what you memorize, and we want you to be able to solve a problem. Any questions so far?
Nope, keep going.
Okay, good. By the way, for your first, I'm not sure if you submitted the second delivery feedback, but that is for the first one. If you have any questions, you can just reach me later, either through group me, email, or like set an appointment. By the way, tomorrow I have a big surgery, a big oral surgery, and hopefully, most likely, I will be able to teach you on Wednesday. It shouldn't be that much hard, but in case I have a lot of inflation in my mouth, maybe I record the session and post it later. But hopefully, if the surgery would be successful, I can easily talk on Wednesday. So just keep in mind for the next Wednesday, I'm not very sure. And also in May 2nd, I have my second COVID shot. So vaccine shot. Again, let's see what is the May 2nd. So May 2nd, okay. So it's Sunday, May 3rd, we have a class. Again, for most of people, there is no issue. So could be something happen. Hopefully, I won't die by then. or there's no chipset in it. There's some jokes about that. So anyway, they are not realistic. So vaccine is really good. Anyway, so in case I have some reaction to the vaccine or to the tumor surgery, just keep in mind for that 2 sessions, I may post the video later, but hopefully there won't be an issue. Okay, so let me talk about it. Okay, so you need to make your Excel. You need to activate solver section or solver add-ins in your Excel. That's pretty easy. Just open an Excel spreadsheet. I wait for all of you for like 1 minute so all of you can open your Excel software. Then I go to step by step and show you how to make the solver ready. So there is no voice, just open the Excel and then we go together.
Professor, I'm sorry, can you repeat the add-in?
I show you step by step now. I just wait all of you open your Excel.
Oh, okay, great.
Okay, go to File. So when you open Excel, I'm not sure how it would be for Mac, but probably similar. So go to File, then the last item is Options. So click on it. So when you click, you see Excel Options. Then go to Add-ins. So on the left side, there's the Add-in section. And when you click on Add-in section, at the bottom of the page, you see Manage Excel Add-ins, right? Here. Just click on Go. And if it's first time, Solver Add-ins is not selected, just select Solver Add-ins here. So it would be a tick mark here. Then press OK. Now, your Excel can solve prescriptive analytics problems. You might see in the Data tab, there's a Solver section. When you click, it's Solver. Okay, let's do it again. So just open a blank Excel sheet, go to File, then go to Options, then Add-ins, then at the bottom of the page is section Excel Add-ins, select Go, then select Solver Add-ins here, this option, the last one, and press OK. So if you do that, when you go to Data tab, you see a Solver section at the end of the right part. If it's Mac, it might be a little different. So my Mac doesn't work properly, but just Google how to make Solver ready in the Mac OS. If you couldn't, just reach me later so I can show you, or you can post on GroupMe so your friends can answer you and get a bonus. So that could be a good deal too. That's it, pretty much easy. So let's look at the sandwich hash brown example. So, okay, I give you like a couple of minutes to go to the previous week, open that problem, and just review it. So in case you forget, let me, if I can find it on my system. I think it must be 9. Okay. You can read from my monitor or just open the week 9 and look at the that week problem. A Clark alumni owns a fast food restaurant named LP Clark. Sorry. He plans to start a new family meal offer containing sandwiches and hash browns. He has to make a decision that how many sandwiches and hash brown to include in the meal offer. So number of sandwiches and hash browns are a decision variable. You should make a decision of how many of them you should prepare. His objective is to design a meal with minimum cost. So the goal is minimization. And probably we have objective function that make our cost. However, there are few requirements of the plan. So whatever you see here, these are the policies. So, or like constraints, or basically based on nature of problem, you might see some information here. The cost of sandwich is $5, hash brown is $1. Okay, the remaining are policies. Meal should be at least 1,000 calories. The meal should contain at least 6 grams of protein. The meal should not contain more than 80 grams of fat. The meal should contain at least 1,000 grams of carbs. So, based on this decision variable, we need to build a function that make our cost. These are the coefficient of those decision variables, 5 for sandwich, 1 for hash browns, and these are our policies. This table also talks about basically more information about decision variable. For example, if you decide to make a one sandwich, it make 300 calories to 20 grams of protein, 20 grams of fat, 50 grams of carbs. For one hash brown, it makes 200 calories, 5 grams of protein, 10 grams of fat, 30 grams of carbs. And these are basically coefficients that affect our constraints or policies. I hope this problem is straightforward, and last week you didn't have class on Wednesday. Hopefully now you make a review and this problem makes a lot of sense. Okay, so let me open. So this is my objective function. Why I'm saying function, look at, this is the coefficient, 5 is the coefficient of cost for sandwich, and for hash brown, I have coefficient of 1. And it comes from here. These 4 are my constraint or policies. So that problem or that meal program had some policy in terms of calorie, protein, fat, and carbs. So I know for calories, it should be at least 1,000 calories. And that 1,000 calories comes from hash brown and sandwiches. Based on my problem, I know for each sandwich that I decide to make, I produce 300 calories. And for each hash brown, I produce 200 calories. These are the coefficient of that constraint. Same for protein. So for each sandwich that I decide to make, it makes 20 grams of protein. For each hash brown that I decide to make, I make 5 grams of protein. And the policy is that no matter of how many sandwich or hash browns you produce, the amount of protein should be more than 60 grams. And same for other constraints. And also we know that number of sandwich and hash browns shouldn't be less than 0. Negative sandwich and hash brown doesn't make sense at all. We talk about integer values, so number of hash brown sandwiches should be integer. But again, these are the very basic classes that we have for prescriptive analytics. We relax some of the constraints, for example, integer values. But let's have at least, doesn't make sense to be negative. We know 0.3 sandwiches is absurd or silly, but negative sandwiches, it doesn't make any sense. Okay, I give you like a couple of minutes to look at this formulation. Then you can go back and forth on basically write-ups of the problems and how we formulated here. Okay, sorry. Meanwhile, if you have any questions, you can just ask me. But please just compare the formulation here with the write-ups of the problem. Because from now, you need to learn how to formulate it. In the final exam, maybe I ask you how to solve a problem through visualizations. But for if it's your project or other assignments, you just need to formulate it mathematically, and the rest is easy. Just let Excel solve it for you. Okay, so hopefully, nobody asked me any questions, and I don't see any in the chat room. But again, at the end, we should decide about how many sandwich and hash brown with S and H to produce. That affect our cost because we have a coefficient for the cost. And for each constraint or policies, each decision variable has different coefficients. At the end, we want to follow all the constraints and basically minimize or maximize our objective function. Okay, I posted an Excel file. The name of Excel file is in-class solutions. Please download and open it. I give you like 1 or 2 minutes to do that. And when you download it, please open the first page, which is problem 1. If you want me to teach faster, please let me know. I just assume there are different people in different parts of the world, so it's the reason I pause in case you have questions or if there is some internet issues, so all of us would have the same speed. Let me take a picture from it. Larger. Okay, so as you see, I just put S and H here as my decision variables. One line is for my objective functions. So as you see, coefficient of S is 5, coefficient of H is 1, is because like sandwich costs $5, hash brown costs $1. And these yellow cells are amount of my decision variables. Depends on how many sandwiches and hash browns that I produce. I have different costs. So just as an example, at least one of you answer me. Let's say I solve this problem through Excel, and the Excel would tell me make 2 sandwich and 1 hash brown. What would be my cost, or what would be the value of my objective function?
It should be 11, shouldn't it?
Yeah, so at the end, if you say 2 sandwiches, 1 hash brown, look at here. So it's how I make this cell. Let me delete it. So if you click on this cell, you see the formula. So it's a C5 coefficient of sandwich times C4, which is number of sandwiches, plus D5 coefficient of hash brown, which is 1, times number of hash brown. Let me exit. At first, when you open it, there is nothing. So 0 times 5 plus 0 times 1 would be 0. But if you solve it, let's Excel solve it for you. 2, 1, 11. So I just threw a random number. Look at now for each constraint, I have a 1 line. Look. So again, let's say I have 2 sandwiches and 1 hash brown. 300 is the coefficient of calories for sandwich, as 200 is coefficient of calories for hash brown. How many calories would have my meal? It's as easy as before, at least one of you should tell me. So with 2 sandwiches, S is 2, H is 1. How many calories my meal would have?
800.
Yes. Yeah, so 2 sandwiches times 300 calories. This is the coefficient you see in this yellow, creamy rectangle. 1 hash brown times 200 calories, which comes from here, would be 800, right? So again, let me just delete it. At the first, when you open it, all of them would be 0. 1 for formulating the objective function. The other one here is formulating for calories, protein, fat, and carbs. Let's look at the protein calories. C7, coefficient of calories for sandwich times number of sandwiches, plus 200, which is D7, times D4, which is the number of hash browns. First is 0, we just threw a number, 2 and 1. Look at 800. If we make 2 sandwiches and 1 hash brown, the overall calorie or total number of calories would be 800. Based on the policies that you see on the creamy or in the right rectangle, do you think, is there any issue here in this red one?
There is.
Yeah, what's the issue?
I mean, because the total calories is 800 and we want a minimum of 1,000. So that's not.
Yeah, we haven't followed the policy. Yeah, very correct. So Tobias was right. Look at here, 800 calories, but we didn't follow the policy, right? So 2 and 1 was not correct. Let's look at protein. Even we didn't follow the concept for protein. So if you look at the formula, it's just like 20 times sandwiches, 5 times hash browns, same as on the rectangle, and 45, less than 60. It should be more than 60. What about fat, this yellow, blue line? So did we follow the policy for the fat?
Yes.
Yeah, Josh was right. So with 2 sandwiches and 1 hash brown, 2 times 20 plus 1 times 10, 50. Look at the policy or constraint. It said meal should have less than 80 grams of fat. We followed that. And same for carbs. We make 130 carbs, grams of carbs, which is more than 100. We follow the constraint. So one way you can just throw random numbers and see if what happens, but it's not the case. It's not efficient. It might take forever. So now we can ask Excel to solve it for us. So when you open it, just disregard this. Let me just make everything in the same place. So when you open it, first of all, the objective function is 0, and also for value of each constraint is 0 too, because in the yellow cells, we didn't put any number. And we have seen that if you do randomly plug some numbers, we may or may not reach the optimum or minimum cost, or even we may or may not follow constraints or our meal policy. Now let's Excel does it for us. So just follow my steps. Go to data tab on Excel. If you already put the add-ins, the solver should be here. Click on it. So again, let me do it again. So first, Excel will be in the home tab. Click on Data tab, and Solver should be on the right side or somewhere similar to that. Click on Solver. So when you click on Solver, you already see I put the solution, but this is just for a practice. So look at the first one. Set objective. I said E5. E5. Oh, what happened? So E5 now is 0. It's basically my objective function. And you already know, let's just close it. So in E5, I put C5 times C4 plus D5 times D4. And this is formula for my objective function. I'm telling Excel, at the end, this is the objective function. And look at the second item, I said mean. I'm telling Excel, you should minimize E5. So, but how? Excel should search for numbers. Look at here, just saying search from C4 to D4. C4 and D4 are those yellow cells. These are my decision variables. What I'm saying from it to Excel, I want you to focus on E5. This is the cell that has my objective function value. I want to minimize it, but how you want, the way that you minimize it, just searching different numbers for C4 and D4. Any questions so far? Sorry, I'm pausing a lot because I cannot see your faces, and like it's an online class, so I should pause so to see if anyone has a question. I wait 1 minute, so in case you read, and if it brings any question, I just answer. Okay, so far it was very easy. First, you select the cell for your objective function. Let me just delete this. So in the next time, you don't see any solution, so you should solve by yourself. So just click on this cell, and click on E5, which has the location of my objective function. Let me delete this one too. So now I should select the location of my decision variables, these two. Look at here. Okay, so far we are good for objective function part and also identify decision variable. Now we should plug our constraint or policies. So first constraint is total number of calories should be more than 1,000. So how you calculate the number of calories? It's just coefficient of sandwich calories and hash brown calories times to their the value of their decision variables. But at the end, I save everything on E7. Right? Let me delete this one. Okay. So I just delete the how to make the policy for calories. So at the end, the value of calories are in E7, and I formulate it in that way because E7 just means multiplication of calories coefficient to their decision variables. Based on my policy, whatever I make, whatever number of calories that I make should be more than 1,000. Then I go to add the constraint. Press add. The reference should be E7. Is it less or more? Look at here is more than 1,000. So I'm just saying that more than equal. And you see we have some integer binary, so we talk about them later, but again for today we just relax it, all the realistic limitations. So E7 is calories that comes from formulation should be more than 1,000 here. So F7, which I just click on it and popped here, is basically a number of, the policy for the calories. So I'm just, again, E7, whatever number of calories that I make based on the formula that I plug in should be more than F7, which is 1,000. Press OK. And you do same for protein. For example, for protein, it should be E8 more than F8. So look at here, E8 more than F8. For fat, E9 should be less than F9. So E9 less than F9. And for carbs, it should be more equal here. So it should be E10 more than F10. So E10 more equal F10. Here, I'm just saying that make unconstrained variables non-negative. So it's like S and H should be more than equal 0. And here, I'm just saying that pick Simplex LP. Simplex is the method that Excel uses for solving this problem. Let's say it's similar to not similar, but it's kind of, in terms of similarities, like you use neural network, SVM, decision tree for predictive analytics. Here we use Simplex LP or Simplex linear programming for solving prescriptive analytics. Then just select solve. So you can press OK and just see the value, but on the right side, just press Control, then click Answer Sensitivity Limits. first, none of them would be selected. Just press Control and select one by one. Then press OK. Okay. First of all, there's 3 Excel sheets here. And they also have the solution. So the cost is 14. So S2, sandwiches 2, H4 or hash browns. And it talks about some of the constraints. So we go over them later. But now go to the sheet problem 1. Let's check one by what happened. So first of all, Excel solved it and told us 2 sandwiches and 4 hash brown you should make. So 2 times 5, the coefficient of cost for sandwich is 5, coefficient of cost for hash brown is 1. So 2 times 5 plus 4 times 1 is 14. So just see if we, and thanks God, they are like integers. So we are not worried about integer values here. And look at calories. So 2 times 300 plus 4 times 200 is 1,400. Look at the first constraint is more than 1,000. So it's good. We follow the first constraint. What about the second one? We made 60 grams of protein. So based on the second constraint, it should be greater or equal to 60. So we pass it. Same for fat. We are equal 80, which is, it means we follow the third constraint, less or equal 80. For carbs, we made 220, more than 100 carbs, which is the last constraint. So we are good so far. I just wait 1 minute to see if you have questions, then I go to the next part. By the way, no worries if it could be challenging or have questions. It's the first time you see such a problem. In the next classes, we go over transportation problems. So you see a new type of problem or production problem. You see new types of problems. So each time might be challenging because first time you see such a problem. But next time, if you see similar problem for making meals, it's easy. You just easily can set up the formulation. Okay, so we are seeing some here, like not binding or this one. Allowable increase, decrease, shadow price, reduce cost. So let's see what they mean. Okay. Please go to Moodle and download the concept Word document. The name is More Concept. And here we just follow some, we just review some basic language section. So there is some terms that makes something in linear programming. Again, I don't expect you to memorize all of them, but we just want to know what they are talking about, what they mean. So maybe when you look at the report, those report makes more sense. The first one is binding constraints. It just means a constraint that participates in the final optimal point. You remember we had some, in the visual analytics, we talked about the points. We said that optimal solution should be on the points. We don't have to search for whole the feasible region. We just check the edges and points. And these are basically, that should have our optimal solution. Let me draw 2 lines Mm, okay. So let's say I have a feasible region with these 3 lines. These are my constraints, and in the middle, I have feasible region. Based on visual analytics, we said that the points, those blue points, have my optimal solution. So if I want to search for optimal solution, I just need to check the points that comes from the boundaries of my feasible region. So those blue points are intersection of those 2 constraints. So binding constraint, let's say, let me just make another one. Okay, so I'm just showing this circle to show my optimal solution. Let's see optimal solution here, that blue line. Can anyone tell me what are my binding constraints? Which constraints make that blue edges that is my optimal solution? Talk about. Maybe I can just send them down. So look at my optimal solution, that blue line that I'm showing here. Which constraints intersect with each other and make that point, that intersection point, that blue line? Just tell me the line colors.
Red and black.
Yes. Red and black intersect with each other, creates one of those blue dots, which is my optimal solution. So the red and the black lines are my binding constraints. Let me have another problem, and this would be my optimal solution. Now, what are my binding constraints here? Which line colors are my binding constraints?
Green and red.
Yes. So basically binding constraint is, there's no math behind of that. This is just some language thing. So in the linear program, when they are talking binding constraint, they just mean which constraints lines intersect with each other and make an optimal point for your final solution. That's it. So very straightforward. So now talking about surplus and slack. By the way, in the Excel, both of them are same. They just mean how you're far from the right-hand side of your constraint. In the surplus, the amount of by which left-hand side of greater than equal the constraint exceed its right-hand side. Put up the formula greater equal constraint and find LH or right-hand side or left-hand side. So LHS means left-hand side. RHS just stands for right-hand side. Similar slack just means amount by which left-hand side of the less than equal to constant lags its right-hand side. Might be a little confusing, but let's look at our problem here. So look at calories. My optimal solution saying that I produce 1,400 calories, but I just need 1,000. So this is let me just change the color. So the yellow is right-hand side. Sorry, the blue is right-hand side. The red is left-hand side. Here, my slack is 400, just left-hand side minus right-hand side. Or it just means how I'm far from the board threshold of my constraints. Look at this protein constraint. Is there, what is my slack or surplus? What is the differences between right-hand side and left-hand side? It is 0. So both of them are same. So it just means you made on the edge or on the threshold of your constraint. What about fat? What is my surplus or slack? Can anyone calculate the slack for this problem, for this constraint? What is the difference between right-hand side and left-hand side?
0.
0. So again, in that definition, I differentiate the slack and surplus. When it's less or equal, you have a slack, like fat. When it's more or equal, you have surplus. But in Excel, both of them are same. So when you look at other people's write-ups, they differentiate for less or equal problem or greater than equal problem. But in Excel, both of them are same. So let me just go back here. So surplus and slack just means how you are different from right-hand side. In the last one, based on that definition that I gave you, we have a surplus because of is a greater or equal problem. And we made 220, 102 more than what we need as a threshold at right-hand side. So again, in Excel, you don't have two definitions. It just say for either greater than equal non-equality or less than equal non-equality or equation. You just have same as a slack. So the next one is shadow price. Let me just read from it. The change in the objective value when a resource or constraint is relaxed by 1 unit, keeping everything else constant. just simply means here you have some thresholds for your constraints. What happens if you change it by 1 unit? What if you increase it by 1 unit? What happens to your final solution? Let me make, sometimes it doesn't change anything. So then, let me just change it to 61. Go to data, solver, solve it. Look, it changed. Now it's 14.3. Let me just change it back. So as you saw, when you change, I think I should, okay, never mind, I should fix it later. But anyway, so when you change the right-hand side, it affects the objective function. So let's just put the 61. So it's what shadow price talking about. They changed the objective values. Do you see the change? It used to be 14, now it's 14.3. When a resource, so the name, so again, we have different names for the same thing. So when we talk about policy, resource, or constraint, they're actually same. Is relaxed or increased by 1 unit, keeping everything else constant. Allowable increase or decrease, maximum change from current coefficient that kept the optimum solution. It just means now the coefficient is 5 and 1, the coefficient of decision variable. How much you can change them? For example, if you change 5 to 6, would it change the number of sandwich or hash browns? And considering that you should follow the policies. What if I made it 4? Again, we want to see, does it affect our number of decision variables? So for sure, if you change these coefficients, it would change your optimum solution. But the change that we are talking about is about for the value of decision variables. We want to know if we change it to different numbers, does it change our number of, does it change the value for decision variables or not? Let's go back to 60 again. Okay. And we talk about, okay, so it said, okay. I'm cheating here. I'll teach you later how to cheat, but let me just change it to 6. And as solve it again. Do you see the objective function changed, but not the decision variables are same. What if change it to 3? Now my decision variable changed, right? So here, what we meant from allowable decrease or increase just means maximum change from the current coefficient that keeps optimal solution. What I mean optimal solution, it just means the value of decision variables. How much should we change? So it just means, so just let's say for the, I think we should go over a better example, but again, we are at the end, we want to know how can we play with this coefficient that which they don't change our decision variables. Later we do more practice, hopefully it makes a lot more sense. Reduced cost. the amount by which an objective function coefficient would have to improve to include it in solution. Otherwise, it would be 0. So here, let me just change it to actual values. Both of my decision variables are included because their numbers are 2 and 4. Therefore, based on this, they would be 0. So reduced cost of my decision variable are 0 because they are already in the optimal solution. I already know that I need 2 sandwich and 4 hash browns. So reduced cost is 0. But let's say one of them are 0. It just means it's not in the optimal solution. The decision value, the decision variable has the value of 0. It just means it's not in the optimal solution. Now say the amount by which objective function coefficient have to change that that it would be included in the solution. It just means, what if I make it 4? It would be 1 or more, right? So it's just saying, how much should I play with this coefficient? So at the end, number of the decision value should be more than 0. Okay, today I taught a lot. We talk about this. So, and at the end, you just need to know what they mean. I don't ask you define me surplus, slack, or shadow price. So, and again, in the Excel, these two are same. So Excel doesn't differentiate between greater than equal, this one, or less than equal. So, but I teach you another software that differentiates between surplus and slack, but at the end, it just means how you're far from the threshold of your right-hand side, or threshold of, this right-hand side is 1000, 60, 80, 100, how you're far from that threshold. Okay, that's for today. Again, just for your practice, please come here. I think you can read these reports. So report 1, sensitivity report, limit report. So based on that dictionary, just read what do they mean. Maybe you can play with this coefficient or play with your policies and then see what happens in terms of optimal solution, decision variables, so on and so forth. Any question for today?
I think you're good, Professor.
Okay, good. So, based on the feedbacks that I gave you for report, your first delivery, if you need a meeting, please set it up. And hopefully for this Wednesday and next Monday, there won't be any issues, but just be prepared in advance. And that's it for today. I know it's too much thing, but again, at the end, you just need to practice and just expose yourself. And I think if you just compare these values with these reports, it makes a lot more sense. Thank you very much and have a great rest of the week. Bye.
Thank you.
Thank
Thank you.
Thank you, Professor.
Thank you, Professor.